Okay, we're just gonna start off with the concept of sleep, alright? Because normally sleep will help you to save power when you are not using things, right? Because many microcontrollers spend a lot of time doing nothing, alright? Because there's only a few times where the sensor is activated, then you do something. Then if the sensor is not activated, then your microcontroller is actually doing nothing, which is wasting a lot of power, a lot of resources, alright? So therefore we introduce the method of sleep so that you can actually save a lot of power and not to waste any power at all. And therefore in order to sleep, alright, what does sleep gonna do with your system? Alright, how does sleep gonna do with your microcontroller? Alright, firstly you're gonna turn your main clock oscillator to stop. Alright, I will assume that this clock itself is talking about the SCL. Alright, the serial clock system. You can watch in V7 part 9, alright, talking about SDA and XCL, alright, talking about I2C, talking about the buses and things like that, alright, how connections are being met, alright, because normally you have many components in your microcontroller. So in order to connect all the components, you need a bus. Alright, these lines are called buses to allow communications between one device to another device. Okay, so this bus is actually called the I2C. I2C itself have its own clock system. Alright, nonetheless, I may still assume that the whole microcontroller itself may still have another clock system somewhere. Right, we call this the main clock oscillator. Okay, but there is actually many clocks. Alright, instead of just only the I2C clock, you also have the main clock. You may also have the very secret clock, which the watchdog timer, our previous video also talk about. Alright, timer itself has its own timer and its own counter. Alright, so in some sense it also have its own clock. Alright, so there is many clocks, so be careful of what clock you are using. So in this case we are talking about the main clock, or the main clock that runs all your stuff all over in the microcontroller. The clock will control the workload of whatever thing that you're talking about. Alright, so it is the main clock that will deals with your main stuff that you're gonna do, right? So therefore, if your main clock oscillator stops, or you wouldn't have anything to work. Alright, now everything goes to sleep. Alright, all the devices cannot work because the clock itself has prevent anything from working. Alright, so everybody is sleeping. Alright, except some of the hidden clocks that don't sleep. Alright, and then executions of instructions therefore would all stops. That's what you say, because all your clock is stopped, so all the devices cannot communicate with each other. Alright, so therefore there is a wire called I2C. Alright, but I2C is the clock also being stopped. Alright, so therefore the devices over here cannot communicate with this device. Alright, so execution for instructions all stops because you cannot communicate between devices and devices. Alright, or components within itself. Alright, this whole thing is a hardware. Alright, and within this hardware there is many few devices, or you can say components also. Okay, so be careful of the terms that I'm using. Alright, so this whole system right here is your microcontroller. Within your microcontroller has many little small components, many little small devices. Okay, so in order to communicate between these devices, you need a lot of wires, a lot of I2C. Alright, the I2C to help you communicate. But since the clock stops, everything stops. Alright, no communication is gonna be on. Alright, so the clock itself may most likely be the SCL, but I will still assume that there may be another main clock. Alright, so be careful. Alright, SCL is for I2C. Alright, the main clock is something maybe different from different from I2C, maybe something else. If you don't know what the hell am I talking, what I2C or whatever, what SCL, whatever, just watch this video. Okay, just check it out. Okay, unless you can watch its other videos all along here. Alright, then you can understand better more. Alright, next is that all data in memories is retained. Alright, so although the power is lowered, but it is not off. So if it's cut off, this means that your memories are all erased. Alright, or most specifically, your RAM memory will be erased, because RAM memory are called the volatile system. Alright, volatile means that once you off the power, alright, all the RAM memory will be gone. Alright, so you wouldn't have any memory left. So the next time you on, alright, the RAM memory will be a refreshed one. All your past information is gone. Alright, if you're talking about ROM memory is talking about your D drive, your memory, SD card, whatever. This is all called the ROM. Alright, it's a non-volatile system. Okay, so be careful. So therefore, if you were to lower your power, you didn't off your power, actually your RAM informations are all still intact. Alright, it doesn't erase. Alright, so therefore it says that all data in memory is retained fully static. Alright, so this term is called the fully static, I would say. Alright, so at least you get a meaning of that. If you don't know what is RAM, what is ROM, what is what non-volatile volatile thing, okay, you can also watch this video. Alright, chapter 2. Okay, there is the definitions in there. You just watch video chapter 2 in the playlist. Okay, so if it's sleeping, alright, the output itself will still remain active. Other components will off. Why is that so? Alright, best way to explain this analogy is to use this thing. Alright, imagine we have an input. Alright, to like this analogy is talking about army. Alright, so if you have a certain input to the commander, alright, the commander will actually tell the officer to do something. Alright, then the officer will tell the sergeant to do something, and then the sergeant will tell the man to do something. Alright, so the man has nobody to call anybody to do something, then he will do himself. Alright, so he will turn whatever thing you want. Alright, so he will do all the chores, all the very very little stuff he will be doing. Alright, so every time it's only this particular man doing things. Alright, while all these things over here are all idling. Alright, so therefore these things are idling and gonna waste your resources, waste your time. Alright, so therefore you're gonna put them to sleep. Alright, this is something the same meaning. Therefore, coming back to this, if you have a certain input, alright, to a certain receiver, the A will say, okay, I receive something. After that, then I'll pass the information to B. Then B will pass the information to C. C process a little bit and pass the information to D. And at the end of the day, the D only the D is doing something. Alright, so the D itself is just the output. Alright, its purpose is to output things only. Its purpose is to do things. Or the A, B, C are all idling. They didn't do anything. Their purpose is only to process information from one place to another. Alright, to make things for the output to do some things, to know what is the guidelines and things like that. Okay, so the ABC itself most of the time is not doing anything. Only the output is doing the thing. Okay, so therefore this means that the output remains active, but of course will not change their values, because since after it received the instruction over here, you will not change anything already, unless you have a new input. In this case, if it's a new input, then new input will go to B and go to C and go to D, then you will change the D output. Alright, things like that. So otherwise, if nothing changed, alright, the D will output the same values or same things all along. Okay? For these four conditions are all talking about your controller when it is sleeping. When your controller is sleeping, these four things will execute. Alright, it will start. Correct? And the current drawn from your when your system is asleep, there will be still current going on. Okay, but it's very very low in modern microcontrollers. Alright, so the datasheet actually claims to have 2.5 microampere. Micro. Alright, for the SEM3X. But for some PIC controller, microcontroller, or PIC, I would think is proportional integrated controller, I think. But anyway, this PIC controller will actually go below 1 nanoampere, so it will be more smaller than your 2.5 micro. Alright, so it's to the power of 10 to the negative 9. Micro is 10 to the negative 6. Okay, so therefore when you're sleeping, you actually have very very little current to do work. Okay, and last but not least, the sentence it says that ensure that all inputs are VSS or VDD to keep the current low. Alright, I don't know what the hell, but you just memorize this sentence. Alright, VSS and VDD, you keep it low. If you keep your current low, then you can save a lot of power. Alright, because I will assume that your input is VSS and VDD. Alright, you're gonna drive the output. Alright, drive the output. So eventually the output will do certain stuff based on the input. So the input tells the output to do, maybe it takes in more current. Alright, then the output will keep on taking in more current. Alright, so although everything is sleeping, but the output itself takes in more current. Alright, compared to the previous process. For example, in this issue, alright, if it's this processes over here, the new input, alright, tells the output over here, your fan, to turn at speed 1. Okay, then after that, as time goes by, another new input comes in, go through all these processes and tell the output to go to speed 2. Alright, so over here as you can see, this speed 2 is much faster than speed 1 already, correct? So therefore, although this is much faster, the current drawn from your speed 2 is higher than your speed 1. For example, speed 1 takes in 5 milliampere, your speed 2 over here gonna take in 10 milliampere. Alright, so it's taking more current than a lower one. So normally we want to have, when the system is sleeping, you want it to have the lowest current as possible. Alright, so you want your input to be at the lowest, so that your output also be the lowest. Okay, so your VSS and your VDD, alright, are your inputs. Alright, your VSS, I think is ground, I forget. Your VDD is your input. So your VDD is your input, your VSS I think is your ground. I don't know. Alright, I forget, but at least you get a meaning of that lah. Alright. So I think this is it for talking about the sleeping issue. Alright, so in the next video we'll talk about how to wake up from the sleep. Alright, what are the things to take note of wake up from the sleep, and maybe strategies for saving power. Alright, so see you there.